Hiya! So in this video, we're going to look at left and right orientations or bases, and we're going to in particular look at examples of these to kind of see how they kind of work and where the structure is kind of coming from. So let's look at these. So let's look at an example. So the first example we're going to look at is I'm going to look at a basis EF. So I have two vectors EF in my vector space. And we're just here. Remember, we have a choice. We can say EF either has a left or right orientation. It doesn't really matter. You can choose. For us, we're just going to say it will have a left orientation. So we arbitrarily chose that EF has a left orientation. And we're going to look at three different bases. E minus F, F minus E, and FE. So this is 1, 2, 3. And we're going to ask which ones have right orientations and which ones have left orientations. So how do we do this? Basically, remember that something with left orientation is going to have the same orientation as EF, and something with right orientation is going to have the opposite orientation as EF. So in other words, what we have to do is we have to figure out what the orientations are for the bases. Okay, so from EF to E minus F, what is the transition matrix? Well, what is the transition matrix? We'll just put T since I didn't really write letters for these. The transition matrix here is, well, E goes to E, so this is just 1. And F is minus F, so 0, minus 1. So this is our transition matrix. And the determinant of T, in this case, is just minus 1. So it has opposite orientation, therefore opposite orientation. Therefore, E minus F has a right orientation, since it's opposite to the left orientation. All right. Now the cool thing about this one is basically it's a reflection in 2 dimensions. So let's kind of see what this looks like. If I have my two vectors E and F, so here we'll say this is E, this we'll say is F. Here I chose an orthonormal basis, but it doesn't have to be. Actually, let's choose something that's not an orthonormal basis. Bam. Do this. F. And what is F minus? It's this vector here, right? This is minus F. Well, all this is, if you kind of think about this, this is like if I had some plane. So let me draw this nicely. So if I have some 2-dimensional plane here, and I basically reflected F over this plane. So in other words, like for example, E reflected over this plane would look like that or something like this, right? So this is the reflection of E. Minus F goes to minus F, etc. So this is just a reflection over this plane. So it's kind of cool. Okay, so number 2. Let's look at what number 2 looks like. We're going over this because we will eventually talk about reflections and rotations and fun little things. So 2 is F. So E, let me choose black. F is E. F goes to F minus E. So what is the transition matrix? T is, the first one is F, so we get 0, 1. The second one is minus E, so we get this. So the determinant of T is 0 minus 1 is 1. So since this is determinant minus 1, therefore F minus E has a left orientation. And what does this look like? So here I have my E and F. What does F minus E look like? So let's look at these together. So here I have, can we see down here? Yeah, we can. Okay, so if I take F here and I take E here, what is F minus E? Well, F stays, minus E comes here. Minus E? I guess this one's a little harder to see, but it's supposed to be a rotation. I guess it doesn't help that. Here, we'll do this. We'll keep this as is. F. Because it makes more sense in this case. Okay, so what we have is this is actually a rotation. Now, here, if you look at this, it might look like a reflection, right? And the reason why this is actually a rotation and not a reflection is because the ordering here matters. So here, let's kind of look at this. So the first one we have, our first basis is this. So it's 1, 2, right? So this is our 2 basis. Now, in the second one, our 2 bases are, or 2 vectors, are these 2. But this one is first, the top one, and this is second. So in other words, you can kind of think of this right angle just got rotated over. So this is just a rotation of everything over by 90 degrees. Okay, so that's both of these. Let's look at one other example. Do I have room to go down? Yeah, I have room here. So the third one takes us to FE. So what does FE look like? So EF goes to FE. At this point, this shouldn't be too hard to see what we're doing. So here the transition matrix is 0, 1, 1, 0. The determinant here is -1. In other words, FE, they have opposite orientation, right? Because the determinant is negative. Therefore, it has the right orientation. Right orientation. And what does this look like graphically? So here I have E, then F. E, then F. So here, this is the first one. This is the second one. But then what we do is we flip the order. So this becomes the first and this is the second. So it's kind of like these 2 reversed roles, reversed positions. So the way to kind of see this is actually, if I were to draw a line between them in this way, it's a reflection over this line. So I take the line and I just reflect over that, and I get the new basis. So this is also a reflection. And one thing to note, because we'll use this later on, notice how in number 1 and number 3, the ones with right orientation, we had some reflection. And then in left orientations, we had a rotation. And this will become prominent later on. We're going to go through one other example, but we will save that for the next video. So this was a simple example. We'll do a more complicated one in the next video. So I will see you then. Peace.